Hi guys, it's Miss Clark. Today I'm covering topic 3, sketching quadratics in vertex form, and this is from topic 3 of the algebra review unit. So before we get started, I just wanted to show you what vertex form looks at. So in general, when we say vertex form, we're talking about a quadratic equation that's in the form y equals a times x minus h plus k. So this is called vertex form because it gives us our vertex from the equation. So if we look at our value of h, and we look at our value of k, then we get the vertex h comma k. Now I want you to note here that this says minus h, and so when we're talking about inside the parentheses with the x, the value that we're going to get is always going to be the opposite sign of what's ever inside the parentheses. So this is minus h here, and I have a positive h here. And then my k value is going to be matching the sign. So this is a positive k here, this is a positive k here. So that's going to be my vertex, and then over here in front of my equation I have this value a, and this value a is going to do two things. The first is that when a is positive, I'm going to have a parabola facing up. When a is negative, I'm going to have a parabola facing down. And then the value of a, if it's bigger than 1, it's going to stretch my parabola to be really thin. And if it's between 0 and 1, it's going to give me a nice wide parabola. That was a terrible parabola shape. Let me try that again. There we go. Something like that. So we'll kind of do more of that in the example, but that's just sort of a rough overview. Okay, so going to example 1. So I have this equation right here. It says sketch each quadratic function, include the vertex and at least 2 other points. So I've got this equation, y equals x minus 3 squared minus 2. So the first thing I'm going to want to do is I'm going to find my vertex. I'm just going to do a v for vertex. And I want my h value. And so since this is minus 3, my h, or my x value in the point, is going to be a positive 3, and then this is minus 2, so my k, or my y value in the point, is going to be minus 2. Sorry. So this is the same sign, this is opposite sign. So I'm going to go ahead and start by graphing that point. So I'm going to go over 3 and down 2 to this point right here. And then we can see that I don't really have any number in front of my parentheses, so we can assume that really I just have the value of 1. So this is going to be a parabola that's facing upward because it's positive, and it's not going to really have any sort of stretch to it, so I'm just going to go up 1 and over 1, and then up 1 and over in the other direction. And then I'm just going to try and make a nice parabola that fits through these 3 points, so I'm going to sort of sketch it. And this doesn't have to be perfect, as long as we have those 3 points and we have that nice curve going through those 3 points, that should be sufficient. Okay, so we'll do another example that's like this one. I'm just going to write that equation down again because it's helpful for me to look at it. So if y equals a times x minus h squared plus k. So I'm going to find my vertex first. My h value is going to be the opposite sign of what's in here, so it's going to be minus 1, and then my k value will be the same sign of this, so positive 3. So I'm going to go left 1, up 3 to my vertex, negative 1 comma 3. And then here I have a negative in front of my parentheses, so that means I'm going to have a facing down parabola. So I'm going to go down 1 and over 1 now, down 1 and over 1 instead of up 1 and over 1. And then find the nice curve that goes through those 3 points. Okay, so these are the pretty general terms of what of what vertex form looks like, but now I'm going to show you some examples where maybe there's some pieces missing, and it might not automatically look like vertex form, but we can still consider it vertex form and still use the information of our h and our k and our a value. So I'm going to scoot down to example number 3 now. Just a reminder of my formula. I'm going to write it down again. A times x minus h squared plus k. Okay, so we can see here, as we're comparing my example 3 to my standard vertex form over here, I have my a value, and I have my x minus h, and all I'm missing is my plus k. Now, when something like this is missing, I can always just assume that what should have been there is plus 0. Because this isn't going to change the equation at all, it's not going to move it. Adding 0 doesn't really do anything, but now I can clearly see that this is in vertex form. And so my vertex is going to be positive 4 and 0. And remember here, we're going to plot our x first, so we're going to go over 4 and then up 0. Whenever I see this, I always just want to put that point right there, but we got to be mindful of our x's and our y's. So this is at the point 4, 0. And now I have an a value of 2. So it's positive, it's still going to be facing up, but now instead of going up 1 and over 1, I'm going to go up 2 and over 1. So up 2 and over 1, up 2 and over 1, and just matching that number. So when my a was 1, I went up 1. When my a is 2, I go up 2. Simple as that. Now I've got my 3 points, and I'm going to put my curve through it. Alright. Now as we scoot down to example 4, this one I think is less obvious that it's in vertex form, but we'll go through this again so we can see this really is vertex form. We just can't see all the pieces. So again, I've got y equals a times x minus h squared plus k. Helps me to write this down a million times because then I never forget. Okay, so let's look at what I do have. So I have my a value, I have the number that goes in front of my x quantity squared, and then I also have my plus k. This number that's hanging out past my square is at the end of the equation. So what I'm missing is really this minus h. And so what I can assume then is that this is really the equation, y equals 3 times x minus 0 squared plus 3. And again, you can see this isn't really changing the equation because the 0 would just go away and it would just become 3x squared plus 3. But this is just a nice visual way to see how this translates into vertex form, or already is vertex form. Okay, so then that means I have the vertex at 0, 3. So I'm going to plot that. I'm going to go to 0 on my x value and go up to 3 on my y. And now I've got a slope of 3. And so now instead of going up 1 or going up 2, I'm going to go up 3 and over 1, up 3 and over 1, and then I'm going to graph my parabola. And if I zoom out for a second, you can see how as my a value gets bigger and bigger, it sort of becomes more and more narrow. It's becoming skinnier. Alright. And then last example we're going to go through is just going to be y equals negative 4x squared. So one last time, I've got y equals a times x minus h squared plus k. And so now all I really have is my number in front of my x squared, which is going to be my a value, And so what I'm missing is my h and my k, so I can assume those are both 0. So if I wanted to rewrite this so it looks more like vertex form, I'd have negative 4x minus 0 squared plus 0. Now if you can look at this and tell that you're just going to have a vertex at 0, 0, that's fine. This just helps me to really visually see what's happening to my vertex. So now I've got a vertex at 0, 0. It's going to be right here at the origin. Now I've got a slope of negative 4. So now I've got it's going to be facing downward. And then I'm still going to use that 4 value instead of going. I'm going to go down 4 over 1. And I'm going to go down 4 over 1. And then create a parabola and connect those points. Alright, so these are the basics of sketching a graph for a quadratic function in vertex form. Continue to part B of the video to